Hello everyone and welcome to this video. Okay, let us start our discussion. Today we want to solve a question which is based on a 4 by 4 matrix, and we want to see how we can find its determinant. See, one method is that how we learned before, that we want to start with the row, like take the row element and multiply it with cofactor, then do it for all. But if you see, this is going to be a big question. So indeed we have to solve it but same technique, but there is something which we can do which will make our question easy. Okay, let us use some elementary row and column operations. In this case, when you have a question which is like 4 by 4 or big question and you want to find the determinant, one thing we can do is that we can make reduce the question by performing some row and column operations. Like, what if I try to make most of the elements of this row or column 0, so that it will be multiplied with 0. Indeed, we don't have to do so much of calculation. Like, let us try and see what I meant. Let's say I have this A element matrix A, right? I want to find the mod of this one, so I can rewrite it like this. I have to change the brackets. This is what I want to find now, right? What if I do like this? This is my row 1, right? This is row 1. Can I do like this? If I say R1 minus 2R4, what will be the benefit if I do that? It will be R1, which is 2, minus 2 into 2, it will make it 0. I have a 0 here. Now in a calculator, the best way of doing it on a calculator, how can you do? Use a calculator and do this. Put bracket minus 2 and put another bracket. Now every time here put the first one, like here I want to solve these two, so 2 and 1, put here 2 and 1, so your answer will be 0. Next time you want to do, just replace, go to the replay button, delete the 2, put the next one which is minus 2, put minus 2 here and put minus 1 here and put again the equal to button. It will give you the answers. So if I do this, now when you are performing this row operation, it will change first row only, the first one which is here, not the fourth one. So I have here what, 2 minus 1 is 2 minus 2 will be what, here it is a 0. Now this is the second one, minus 2. Perform the same operation, we will have another 0 here, because R1, which is minus 2 into minus 2 R1, it will make it what, 0. Here we have R1 3. Let's do it manually here. 3 minus 2 into 0, it will be what again, 3. So I have here a 3, right? Now R1, which is 4 minus 2 into 2 will be 4, so 4 minus 4 is again 0. Okay, now I have here 0 0 3 0 by this operation, which is R1 minus 2R4. Let's see, using these operations, can I reduce the second row also? Can I get some zeros here? I want to make sure that I get maximum zeros, so it makes my calculation easy. This is what, this is R1 minus 2R4. Now let's go to the second one. Here it is 3, here it is 1, here it is 3, and here it is 1. Can I do like this? R2 minus 3R4, R2 minus 3R4. It will give me this benefit, like 3 minus 3, it will be 0. 3 minus 3 will be 0. 1 minus minus 3, it will be what, 1 plus 3, we will get here a 4. Now the next one, 5 minus 0, it will be 5, minus 1 minus 3 into 2, minus 6, so it will be minus 7. Okay, I'm getting two zeros here now. Now let's check the third one. What if it's the third one? Can I do R3 plus 5 R4, R3 plus 5 R4. Just take the first element, consider the first one and perform some operation using this so that it becomes what, 0. When it is like this, we have minus 5 plus 5, this will be 0, or let's change color for the next one. Let's use black one. So it is 0, r3 plus 5 r4. So this is, we have here minus 3 minus 5, so minus 8. Here it will be 1 0, so it's again 1, and here it is 0 0 plus 10, it is 10. So what's the benefit? We got 3 zeros, and let's copy the fourth row as it is, 1 minus 1 0 2. So we just performed some row and column operations and we got this, reduced it to this form. We have this. What will be the benefit? Because we wanted to find the determinant. See what will happen. We know the determinant is what? Determinant of a matrix is any row or any column multiplied with its cofactors. Let's take this one. This is a11, right? So a11 into a11 plus this is a21, right? This is a21 into a21 plus a31 into a31 plus a41 into a41. See, if we do not do this operation, if we directly apply this formula on the first matrix A, we have to do a lot of calculations. But what will be the benefit now? The benefit is a11 is 0, so 0 times a11, this term is 0, we don't have to do the calculation. A21 is 0, this is also 0, this one is also 0, and we can apply just one calculation, which is a41, which is 1, and we can find a41. A41 is how you can apply the formula of cofactor, which we learned in the last example, minus 1 into 4 plus 1 into m4 1. So it is minus 1 power 5 into, remove the fourth row, which is this, and remove the first column, which is this. So we are left with what? 0 3 0 4 5 minus 7 minus 8 1 and 10, right? So we are left with what? This is the final answer. A mod is what? Minus 1, because 1 into minus 1 will be minus 1 into the mod of 0 3 0 4 5 minus 7 8 minus 8 1 and 10. See, now again we have benefits. We have two zeros here, so the calculation reduces. How? Let's use the same formula again for determinant, which we learned. It is a mod minus 1 as it is. Now apply. This is a11, so a11 into the cofactor of a11 plus a12 into the cofactor of a12 plus a13 into the cofactor of a13. Here, see, this is a shortcut here. You can understand this also, like here minus 1. Indeed, when you use this one, this is 1 1, so 1 plus 1 is 2, so this term is always, this cofactor will always be positive, so you can directly write it a11 m11. See, this is 1 plus 2, this will be odd power is always negative, so you can write it directly minus a12 into m12, the minor. This is 1 plus 3, this is 4, this will always be positive, so you can write it a13 into m13 directly instead of calculating cofactors separately. Now this is multiplication with this one, so we have a bracket here, m11, because a11 is 0, this term is 0, so this will be what? This will be 0, because this is multiplication. This is also 0, so this term will be also 0. So we are left with what? Minus 1 into a12, which is 3, this is a minus, so minus 3 into m12. Remove the first row and second column is gone, so we are left with what? Here 4 minus 7 minus 8 and 10. This is 3, minus 1 into minus 3 is 3, 4 tens are 40, plus 7 eights are 56, plus here it is 56, but this is 7 eights are 56. Determinant will make it negative. 4 tens are 40, minus 8 into minus 7. So what you will get here, it's 40 minus 56 times 3. The answer will be minus 48. This is one method you can use to solve higher derivatives. Always try if you can make it simple. Question, if it is simple, you can try by using elementary row or column operations. This is row operations. I just use row operations here, like to make them zeros, because I can see there is a 1 here, so this one really helped me to make these 3 zeros, and in a bonus we also get these zeros. So reducing a question makes it easy. Otherwise, if you will not do this, what we have to do, we have to do lot of calculations. What if this is not coming in your mind, then it will be what, a11 into the cofactor of a11, this row will go, this will go, the determinant of this, like minus this one, this will go, and this will go into the determinant of this. Like there will be lot of calculations. This operation made the question easy. We made these zeros and it changed the other values, but it will give us the determinant very easily. That is one method of solving or evaluating higher determinants. That was our target for today. Next time we will see more techniques and methods which will help us in matrices. Thank you so much for your time. I hope you learned something. Thank you. See you next time.